Hi Algebra 2. This is a video about graph analysis, which is about identifying characteristics of graphs of polynomials. So we're going to start with something that we're used to seeing, and that's x squared minus 16. I've already graphed it for us. We can see that there's an x-intercept at -4 and also at 4, and that's the same thing as real zeros. Real meaning that you can see them on a real coordinate plane. Zeros is another term for when this equation, x squared minus 16, is equal to 0. So we can factor it, or we can solve it. So x squared is equal to 16. We know that it should be x is equal to plus or minus 4. The turning point is where a graph changes direction. So here the graph is decreasing, and then it changes and it goes to increasing. So we have a turning point at 0, -16. Now, when we were in the quadratic chapter, we called that the minimum, but because we're in polynomials now, there could be several minima, that's the plural, so we call this a relative minima. If it was maximum, like a maximum, then that would be called a relative maxima, and the overall name for these mins and maxes is called extrema. Extrema meaning like what are the extreme values, so sometimes you have high points and sometimes you have low points. Let's look at situation number 2. Identify the following characteristics of this quadratic. So if I look at the graph, I don't see any x-intercepts of this parabola. So I write none, and let's talk about why. So if I factor out a -2, I get this equation, and again, zeros is when we can solve this equation equal to 0. If I divide by 2, nothing happens. I can try to factor and solve this an easier way, but it doesn't work. So all I can do is quadratic formula. So we'll do opposite of b, plus or minus the square root of 12 squared minus 4 times 1 times 37, all over 2 times a. I'm not going to do the entire thing, but what is the discriminant value? Is equal to -4. So we know that that means that this is going to turn into an imaginary number, which is why we don't see the x-intercepts on the real number graph. These are zeros, but they're not real zeros. So there's a connection here. Real zeros is the same thing as x-intercepts because that's what we can see on a graph, but then there's also just an overarching title of 0, and that's when the entire equation is equal to 0. So in this situation, we don't happen to have any real zeros because we have complex numbers. The turning point in this situation is -6, -2, where it goes from increasing to decreasing. We call this a relative maxima. Situation 3. Here's a cubic. Real zeros we can see are -4, 2, and 4. And let's set this equation equal to 0 and see if we can understand why. So I see 4 terms, so that makes me think of factoring by grouping. So I'm going to factor out an x squared. I'm going to factor out a -16. And then I see that I have a quadratic, which can be factored again. So this explains to me why I have real zeros at 2, 4, and -4, and it's because I was able to factor it and solve it. Even if we end up getting a quadratic, in this term that can be solved using the quadratic formula, you might get real zeros from doing that quadratic formula. They may be rational numbers, they might be irrational numbers, but remember that real numbers is the umbrella that encapsulates irrationals and rational numbers. What we don't define are imaginaries to be in the real numbers. There are 2 turning points here, and we're just going to approximate them. So this is about at -1.848. We call that a relative max. And the next one is 3, -7, and we call that a relative min. Thanks for watching. Have a good night.